So thank you for joining today's session. We're going to go through the process of meeting PCI compliance using Calico Cloud. A lot of what we're covering today's session, we can cover with our open source solution, but there will be some functionality between the actual compliance reporting itself and additional security measures that you might not have been aware of that you can achieve within our enterprise solution called Calico Cloud. So I'll be your presenter today. My name is Nigel. I'm going to give you kind of go over these 5 key points. So the first one is covering what is PCI compliance, what it means to you, why, again, if you have to comply with it, what are the measures you need to adhere to actually meet PCI compliance. I'll cover over why traditional security solutions don't actually help to meet PCI compliance when we're talking about Kubernetes. So it is a different environment together, and there's a bunch of different, again, in its highly dynamic nature, things change, and static rules won't really work for it. We'll go through how Calico addresses those same PCI problems and meets the compliance standard. We'll go through specific ways, again, step 4 on how to actually address those PCI compliance rules with Calico, and then I'll just have some closing notes on this topic. So yeah, my name is Nigel. I'm based out of Ireland. I worked as a solutions architect at Tigera. So that means that, customers who or users of Rancher, it could be users of Azure Cloud or Google Cloud, AWS, no matter where they are, probably, Calico is running in their environment, or they're at least tested at some point. And my job is really showing them value within those solutions. So I've had the opportunity to work with Rancher RKE, most recently RK2. And if you join my other session on Rancher Desktop, you can even get Calico running in those. So I do like working with different Rancher clusters, but even just the broader Kubernetes ecosystem, getting Calico running as your networking plugin and using policy to secure where your workloads within your cluster. So anything Kubernetes and cloud, it's interesting to me. So for those who don't know what Project Calico is, fundamentally it offers a CNI plugin, so container networking interface, that allows you to make the decisions on what workloads should do. So without a CNI plugin, Kubernetes pods don't know how to talk to one another. So it's a pretty critical component within your ecosystem of Kubernetes. Why people might use Calico is, well, there's the CNI, there's the IPAM plugin, which assigns those IPs. And then there's an extensible network policy framework that we offer as well. So, again, if you're familiar with the default network plugin, our network policy plugin with Kubernetes, Calico just offers more than what's in the default implementation. Again, it's fully open source, so free to use. And even the support that Calico offers goes across a bunch of different data planes. So we don't support just standard Linux using IP tables and kubeproxy. We actually support different newer implementations like eBPF, VPP for telcos, and we even support Windows workloads as well, so Windows HNS data plane. When we talk about our policy framework, again, like I say, it's more extensible. You can use it to secure not just the workload pods, but also your VMs themselves if you've got Felix running within those nodes. So even nodes that aren't, VMs that aren't necessarily nodes within a cluster, like legacy to the cluster, we can secure those as well and secure connections to them. It's also, from a networking perspective, it's highly performant. So, when we talk about independent benchmarks, Calico usually comes out favorable. There's a few reasons why this happens. One of the reasons is we're not locked into just using overlays, encapsulation, so IP and IP or VXLAN. We also support the ability to use BGP routing. So without encapsulation overhead, we tend to see performance gains, but also it's highly extensible for that same reason. If we can use BGP to extend to underlying IP fabric, then, we can scale to the limits of Kubernetes really in that scenario. So, it's a highly dynamic environment, scales very well, Calico. And like I say, it performs well against other solutions. So yeah, when we're talking about the policy piece, some of you may be using policy already and already know how it works. For those who don't know why we need network policy, I'll explain kind of what we do with it. So With Kubernetes, by default, it has what we call a flat network. So pods can freely talk to one another without the use of NAT. They can just freely talk across nodes. So in that scenario, there's no inherent security within Kubernetes to secure the workload communication. Since pods are highly dynamic, they get scaled up and down the whole time. They are assigned their own internal IP to those pods. But again, due to their not long-lived nature, those pods tend to die, get recreated, so we call them ephemeral. And as a result, the IP address that's assigned to those pods isn't always there. It's going to change or be replaced with a new IP. So as a result, it's non-deterministic. And if it is non-deterministic, we're not going to build a traditional firewall rule on the perimeter of our cluster and say, secure this IP to this other IP. This is one of the main reasons I was talking about why traditional securities tools don't really help us to secure PCI compliance. We will cover the other points in a while, but in regards to how policy works, we're not going to focus on these, these fixed IPs. Instead, we want to have something else that's somewhat deterministic. So we assign label selectors to workloads. You can do this at the earliest point. So you can do this in the deployment before you create the workload. So as they get scaled up and down, you'll always have this label assigned to it. Now, labels are arbitrary. It could be something like owner equals Nigel, or app equals front end, or app equals database. So once you have a kind of a purpose and intention for those labels, then you can build rules a bit like what you see in the top right corner screenshot, where you can say, allow this label to talk to this other one. So you can allow, say, create ingress or egress rules. So what you allow into the workload, what you allow out. So essentially it's networking controls. You can specify ports and protocols into these rules. And again, Kubernetes has its own standard network policy API. Calico just extends on from that. So in the screenshot you see above, it's networking.k8s.io. R1 would be something on the lines of, projectcalico.org would be our specific API version used. But other than that, we extend on what is already capable in the default implementation. So yeah, I probably already explained this already, but in regards to labels, you can see from the example below, they're a key pair value match. So it's always a matter of, something is set to something else. So you could have a series of apps. So you could have an app that's a database. You could have an app that's, it could be a load balancer, whatever the application intention and purpose is. Then you could have app equals the key pair value match. So the key is the app, and then the matching pair is whatever it is. Again, you can build whatever way you want with these labels, but why I suggest something simple like app equals or, zone equals where you want it to go into is it's very easy to make higher level abstract rules to say anything that's a database, for instance, that handles sensitive data, and we'll come to that in example later with PCI, can't receive traffic from external resources outside of our cluster. So in this case, we can build these kind of generic kind of labels, but build rules within policy to actually lock down those workloads. If this is all new to you and you want to read more about label matching, there's actually a link there to kubernetes.io. I think that's a great place to get started. One other point to mention, and it's kind of, I think it's in the title as well, is that we now support Rancher RK2 as well as RKE. Whether you're using Rancher Kubernetes Engine or the new RK2 cluster type, is when you are configuring your cluster, it's better to use the flag RK2 CNI non or CNI non in Rancher. The reason why I say this is, Rancher will throw in a CNI by default. Probably, I think in this case, it's Canal. But if we use the CNI non, what we're allowing in this case is to have a clean environment of a networking plugin, and then we can freely install Calico into it. This also ensures, because it's in the configuration file itself, that RK doesn't forcefully try to update the default CNI plugin, and that would override the CNI that we're trying to install. So in our configuration file, you can see there, you can either do it in CLI or you can do it in the config file. But if you're doing it in the config file, you just say CNI : non. In that scenario, we can then proceed to install Calico like we normally do. It's a fairly straightforward install process. Usually we use operators. So once you've installed that, as long as you meet the prerequisites, you should be able to do everything we're seeing in today's session in RK2, same way you would be able to do it in Rancher Kubernetes Engine. So an introduction to PCI. So I haven't got to that point yet is PCI is essentially a payment card industry standard, or it's the data security standard. So anything to do with payment details, this is the regulatory standard for that. So a lot of organizations have to meet PCI. It's a pretty standard ask. So I thought it'd be good to make a session around it for today. That's really it. If you handle payment detail, anything sensitive data associated with processing, transmission of cardholder data, then it makes sense that you have a way to prove to an auditor that you are following best practices to secure the payment details. Some examples could be encrypting data itself, so that data in transit, again in Kubernetes by default, workloads that communicate with each other, data in transit. This is more so for RK, not so much RK2, I believe, but it's that, your data is not, encrypted by default. So, it's in plain text in transit between workloads. So in this scenario, we would use a component called WireGuard, and I'll talk about that in a while, to encrypt traffic in transit between workloads. But also you want to build kind of best practices around, sanitizing data. So you want to say, again, like I mentioned earlier about labeling workloads, to say anything that is essentially PCI enabled shouldn't receive traffic from, any workload in the cluster, should have specific workloads to let to communicate with, only over set ports and protocols. And we'll come through that in a while. So I've also got to cover why the traditional solutions don't really apply for it, because, why they don't secure PCI. So, Kubernetes becomes harder and harder to secure by default because, like I say, it's highly dynamic. You're only going to scale up and up and up, most likely with Kubernetes. That's kind of the intention because it's an orchestrator. So as a result, if anything goes wrong, the attack surface is quite broad, it's quite large. And also the ability to remediate is complex. It's going to be very difficult to actually clean off any known attacker within the environment. When I say attacker, it could be a form of malware, and that piece of malware could be trying to talk to a command and control server, and I'll cover that in the next slide. But what we need to know is, by default, it's a flat network, so everything can freely talk to each other. So the attack surface is huge. By using policy, you can at least lock down what workloads can talk to each other, not just within specific network namespaces, but across the cluster. You set the rules on what is or isn't permitted. So we're going for a zero trust approach. Then as companies build up these kind of multi-cloud, policies or multi-cloud approaches of, again, you might have, we're talking specifically about an RK and an RK2 cluster, but you could also have clusters reside in different clouds. You could have one in an Azure cloud, you could have one in AWS cloud. And as a result, you want to have visibility in what the configuration is in each of those clouds from a centralized UI if possible, which is something we can offer in the solution. But also, if, let's say we're only talking about the hypothetical scenario where you have been compromised. In this scenario, to clean up those environments, go to different environments, to take them offline, you're not just losing out on revenue from users downtime where they can't use their service, but also development time that should be otherwise invested in, prioritized in innovation, is otherwise spent in, cleaning up the mess. So we'll go through all that in a while. So here's the generic kind of high-level view of a security landscape we're talking about here with Kubernetes. So the first thing to know is, policy will secure this in a kind of a runtime scenario, but there is security that goes much further before that. So the first part is, let's say you have your developers and they're writing their code, and that code is essentially in this build time process. So, there might be a vulnerability in the image that they're deploying. That would otherwise go into the cluster, and that's how the malware gets there in the first place. That's the basic standard scenario. Also in build time, the developer, to no fault of their own, or maybe in their fault, but it's no malicious intent, is there might be misconfiguration within those images. So again, it could be a version mismatch, something like that, but also it might be just bad code. So in this scenario, you want to be able to scan for these vulnerabilities. You want to be able to understand that there is a potential sign of vulnerability within the code, at the earliest possible stage and use admission control to prevent that from actually getting into your cloud environment. But assuming you don't even do this, and you just deploy anything into your environment, then there can be misconfigurations in the deploy time itself. So on the nodes actually running within the clusters, there might be misconfigurations that make your environment otherwise insecure. So assuming you've failed to comply with these best practices, then the workloads are able to freely talk to each other, because we say by default it's a flat network. So there's no security. If there's a piece of malware in there, we don't know what is malware versus not, because they're all, highly dynamic. They're all talking to each other. So we don't know, we have no visibility into unusual connections established. So in the case of data exfiltration, it's quite easy in this scenario then to take data from the potential sensitive workload like the database, and then maybe try to communicate with a command and control server outside of the cluster. So when you see on the graph there that if we are allowing traffic to external services like a Twilio or Salesforce, because we offer DNS policy as well, which is really nice in our enterprise policy, so FQDN based policy, you want to be able to say, okay, allow only specific traffic, only these ports and protocols. That way, if something comes into your cluster that you don't trust, or that shouldn't be able to talk to those external services, that would be inherently denied. Security also extends onto those external services, VMs inside your environment. And with that, you just have to look at, unauthorized threats that are being sent, to legacy VMs in your cluster. So if you have, like, say, for instance, a firewall integration with this enterprise environment, that's quite nice as well, because you obviously get to bolt additional security into your environment to prevent unauthorized access to legacy VMs inside your internal infrastructure. So the threat goes beyond Kubernetes itself. Again, we're talking about zero-day threats here. So, if we have no inherent security here, like, we don't know it's a threat, we have no way of scanning for it a zero-day, because it is a zero-day. No one knows what that threat is. That's the definition of it. So if there's a compromise, we certainly won't get any visibility, no alerting to notify us that there's this new threat in our environment. And as a result, the kind of malware ransomware, like I mentioned, has the free lateral movement across the cluster. Now, this is kind of the general approach of how the threat actor ends up spreading within your cluster. We'll go through our ways to lock this down, and also to ensure that you meet compliance so that you don't end up incurring a fine or worse when it comes to an auditor trying to check for, are you meeting PCI compliance? So the first part is why traditional approaches are ineffective for PCI compliance. So yeah, like I mentioned, highly dynamic environments in Kubernetes, workloads, can freely talk to each other. So makes sense, right, that we're not doing any kind of security based on IP, like the traditional firewall. In that scenario, if we were to use security groups in AWS as an example, or we were to use, again, the traditional firewall, it's very easy to make kind of high-level generic rules to say, deny any outgoing egress into this environment over certain ports and protocols. You could do something like that, but you could never really target the exact pod, because like I say, when pods die, they get a new name. So, it's not just that they get a new IP, but there's no way of really targeting a specific pod in a specific namespace. So yeah, because of the ephemeral nature, it's very hard to target something if it's highly dynamic. Going on to the next slide. Yeah, compliance timeframe is a big issue. So the more payment data you're handling. So in this case, like if you're a large fintech organization, you handle more than 6 million credit card transactions per year, then it makes sense that you don't just do a yearly audit for PCI. Probably you do them, well, not even monthly, there might even be in some cases weekly, or daily. So in these scenarios, you want to have a tool that will generate those PCI compliance reports to show that you are meeting those best practices, that you're securing your workloads, and that no compromise exists in line with those best practices. But also you want to be able to say this, you can generate a report via cron syntax, so you can customize it so that you get the compliance timeframe that matters to you. And that's something we can also do within our enterprise UI. The next part is that, again, Kubernetes is highly dynamic. So, static compliance controls just don't work. So when I talked about that report, aside from just having the cron syntax, what we can do is we can build the compliance report to say, target workloads based on those labels. So you can say anything with the label PCI is equal to true in any namespace within our cluster, show that they are being secured by policy, essentially on egress and ingress. So in this scenario, whether they scale up and down, we don't mind. That rule is going to be static and consistent and will enforce no matter whether I have 1,000 workloads or 10,000 or 100,000. It really doesn't matter. So as your environment becomes more scalable, then naturally you wouldn't use traditional static compliance controls that say target them based on IP, because already it's not going to work within a couple of minutes. So how does Calico solve all these complex problems? The first one is the access controls itself. I sent a link at the end of the session. So again, if anyone wants to ask about this, I can send it over as well to you. But I'm using our own PCI compliance white paper as the guideline for these access reports or best practices. So you'll see here at the bottom screenshot, you have PCI controls 1.1, 1.1.4, all the way through to 1.2.3 will say that you have to maintain some kind of firewall configuration to protect cardholder data. So although Calico is not a firewall, think of it more as think of policy more as a virtual firewall. They just want to prove in compliance that you have a way of securing the workloads. So policy can do that. From our enterprise policy in Calico Cloud and Calico Enterprise, you can secure egress traffic to external services rather than doing it based on IP. That way you don't open up a larger blast radius. You have a targeted endpoint that you're allowing, say, TCP 443 to tigera.io as a domain name, or api.tigera.io. In that scenario, you can secure, use it like a firewall, but it's much more dynamic in this sense because we're doing it based on label. We can also integrate with the firewall outside of the cluster as well. And if you're using AWS, for instance, we can integrate with the security group that are configured in AWS. So they're their own kind of virtual firewall, except it's just not Kubernetes specific. It's rather for overall infrastructure within AWS. And then, like we say, we can use these controls to secure workload communication on microservice level per pod basis. The next part is 1.1.2 and 1.3. They mentioned that you need to have some kind of a networking diagram, like a topology map of all networking traffic. This is great because Calico collects not just L3, L4 traffic, but also L7. We can get the application level traffic, not by default, but we use Envoy as a daemon set, so essentially a service on the node to collect the HTTP traffic. So if we're collecting all this traffic, then we can, stream it via FluentD to a centralized Elasticsearch UI. And from there, you're adhering to that part of the compliance mark, is that showing here are all your flows, here are all your audit logs. If there's any alerts, like you can see in the graph, this doomsday scenario where alerts are being triggered, you have a topology view, a CDE of all the network connections. And you can meet that part of compliance. So the service to service communication traffic is paramount to your environment, and you should have visibility over that and essentially be able to troubleshoot in general. The next part is 2.2 and 2.4. They mentioned that you need to meet an industry accepted system hardening standard. What we do is I talked about our compliance reports earlier. They link into a tool called Kubench, I believe, and that generates CIS benchmarks. So CIS, the Center for Information Security, they are a reputable company for generating these kind of system hardening standards. So they will say, you should have these feature flags disabled. You should have, only these kind of settings enabled for your systems to make it, inherently more secure. By default, you might not know that certain settings are insecure. So you can schedule these CIS reports. If there's failure in any of the standards within PCI, you can go back and start turning certain settings off where you see fit. But ultimately, you want to be able to, like you see in here, show the auditor that you are meeting an industry accepted system hardening standard. It doesn't mean you're the most secure environment in the world. It just means that you're at least trying to adhere to a recognized standard and you are, using those reports and going back to make your environment more secure. So with that, the next example is for anonymization attacks. So a simple example I can think of is the Tor network. So Tor, if you're familiar with it, like the Onion network, basically, if an attacker is trying to talk to a command and control server, they don't want you knowing that the connection was established to an external IP as part of their, their C2 server. So what they'll do is they'll use a relay network to send the communications through. They do some form of anonymity scan. Then it goes through a relay network to that ClearNet destination that they're trying to reach. So what from a PCI perspective, it's not so much concerned that you're protecting against the Tor example. It's that you're using some kind of IDS, IPS technology to prevent against this kind of malware scenario. So even though we aren't inherently an antivirus solution, and I will go through malware protection in a while, but being able to use a custom resource we call a global threat feed to plug into the IP list associated with the Tor network and the Tor VPN relay network, that way you can essentially let them update their own IP feed, because it is a public hosted IP feed. And the same goes for other threat feeds, like that might be coming from, any security vendor, could be from Trend Micro, could be from Symantec. When they update those IP feeds, then we make a pull request from that. We update the IP list into an object called a network set, and that network set is labeled. And the beauty of this is if you label it something like network equals Tor, then in policy you could say deny egress traffic to network equals Tor. It's a very simple, clear system to essentially implement IDS, IPS via Calico. So the IDS, we get the detection, we get the visibility that those IPs are being used, and even our service graph updates to show connections established to that known bad IP list. And then from an IPS, the protection side, then we can use policy to deny those connections to that external IP list. So yeah, that's a great example. We also have anomaly detection algorithms. So in this scenario, you can, again, it falls under the IDS IPS piece. So this is kind of self-explanatory, but since we're collecting all that network traffic, if we can enable these baseline algorithms, then if there's unusual connections established, different port scanning, IP sweeping, so like, again, think of it like a new pod is introduced and it is malware and we don't know it is, and it's trying to use certain ports and protocols, but our normal baseline data tells us none of our pods are talking to other pods over these ports and protocols. Then you get the alert on it. You're aware that there's an unusual anomaly, whether it's a spike in activity, like a denial of service type attack, or if it's just unusual patterns of behaviors by a rogue attacker, then we get that visibility. We can also integrate with a SOC solution or SIM by essentially streaming the event data via syslog to the additional, log aggregation tool. So yeah, that all plays into the IDS IPS. Also worth noting is how Calico supports PCI compliance requirements in general. So, around policy lifecycle, it's one thing building those policies to secure your workloads, but if, for instance, someone did try to compromise, they got elevated access in your cluster to change policy, or if policy just isn't really working right now, but it did historically, you need to implement some kind of audit trail to be able to show an auditor that, okay, I can see that this service counter user made this change to policy in the last, 4 weeks, in the last 24 hours, whatever it be. So in this case, we record all the policy changes that are made and the connectivity that's associated with those assets. So if it's a change to a pod, if it's changed to policy, if it's changed to a network set, we keep a historical trail of those changes and we can see who made them and at what time. And again, you can then go to historical graphs, see what impact it might have had on the cluster, whether it be allowed or denied traffic as a result of that change. A key point I mentioned there was around encryption. So all traffic in transit between workloads, you can encrypt. And this is the way we implement it is on a node to node level. So what goes on within the node is essentially unencrypted, but when they talk to other nodes, then it is encrypted. To understand what I mean by this is in Kubernetes, like your workloads run in the nodes that you assign within your cluster, whether it's a 2-node cluster or a 10-node cluster or more. So the idea being here is that if it's plain transit data being sent between workloads, and it's, if someone were to sniff it, like they were to do a TCP dump, then they would be able to get the visibility on what's going on between, what data is being sent. So they would have access to that sensitive data, that key holder data or the customer data. So in this case, by simply encrypting traffic via best practice like WireGuard, that way, if they did manage to access that data in transit, it would still be encrypted. It would be unreadable easily to the attacker. So again, as part of this is just to make sure that you're safeguarding data. So one thing, securing the perimeter of the data itself, but also making sure that the data itself is encrypted. And this applies to just about every regulatory standard. So we can do that via WireGuard. I mentioned compliance reports already. So again, continuously auditing, continuously showing that you are meeting standards. And if, for instance, a compliance report tells you, okay, these workloads are no longer secure, then you can go back and change your policy. You can go back and, make changes that make sure that you are complying with this best practice. So it's important that Calico doesn't just show you what's in scope, but also what's also out of scope. So once you know what is no longer scoped in by policy and essentially compliant, how you can then go into policy to make the changes. So yeah, how do we address PCR compliance reports with Calico? A lot of it I think I covered already, but from a policy perspective, I didn't show you actually the code on how we do it. So here's an example using the Kubernetes policy definition, in case that's what you're using. This is using Calico. So you can see in the API version is projectcalico.org version 3. So in this case, all we're saying is, say for instance, the service count SRE account, that's in the namespace called my namespace. And I don't want it to be able to talk to any workload that has the role of helper. So that's the label assigned to it, is role equals helper. Now, if you look at the policy on the left, what it's saying is for ingress, the action is explicitly deny to or from, the service account SRE account. Anything else that might be coming from a different direction, then yeah, you can log that traffic, log ICMP traffic specifically from anything coming in from color is green. So there's a lot of stuff going on in this policy, but basically what we're saying is I'm denying specific traffic, but other traffic that is being sent to it, maybe I want to log it. Maybe I want to keep a syslog activity trail of just kind of those unusual connections established between color green to role helper. We don't care what the pods are or their IP, like you say, they're based on their label, and we're allowing that connection. We're not denying it, but we're also logging it. We're keeping a trail of that activity. But for the compliance perspective, yeah, you want to deny anything with you can do it based on service count. You can do it based on label to label. You can deny on the whole network namespace if you want to do something like that. But how we target the workload is, you can see here, selector role equals helper. So that's what we're targeting, is the workloads via the selector, and then we apply the ingress or egress rows on it. Using the Kubernetes network policy, then you can see I use kind network policy or API version, networking.k8s.io. And in this case, if you want to do a default deny, you just want to deny everything else, like everything. That's targeted for the namespace, my namespace. As you can see under metadata, we're saying the rule applies only to namespace, my namespace. And forward, I want to drop all connections in that namespace. Doesn't make sense why you would normally do this, but this would break all the connections. This is a good system after you've allowed traffic already. So you say, I allow pod A to talk to pod B over TCP port 8080 or something like that. And the same for pod B back to pod A. Once you've allowed only those inherent connections, then you could create something like this, a default deny at a lower order. And that way, any additional traffic will get denied within the namespace. But also, it's worth noting that if, say, role front end, which happens to be in the namespace, my namespace, tries talking to external IP outside of the namespace, that will also get denied. So it's denying all ingress, egress, not just in the namespace itself, but going out of it. So you can prevent those kind of talking to command and control server approaches. A best approach is to create something like a zone-based architecture. So you basically label your workloads, like you can see here under selector, I said FW zone is equal to DMZ, equal to trusted, equal to restricted. If I have a PCI compliant workload, like a database, and I put in a restricted zone, The only way for the traffic to get from public internet to a restricted workload is it would have to go through the DMZ policy. The policy DMZ, you can see it egress is allowed to talk out to, anything with firewalls untrusted. Then it has to go through another policy where the trusted policy then allows only communications, into it from DMZ or trusted zone, and which pods in the same zone. And then it only allows egress out to pods in the same trusted zone or down to the lower restricted zone. And this way, only then if it meets all those rules and conditions, then it can talk to the restricted zone, and the restricted zone also, if it wants to egress out, you can whitelist everything on the database to egress out, because it would still have to go through the relevant zones to get to where it needs to go. So yeah, this is strength in depth via policy, but it's a good best practice is to label the workloads, have some purpose or intention for those workloads, and then, you have security in depth. At the bottom of this, you could even create a default deny, like I mentioned a while ago. So any additional traffic that somehow gets, like a new workload gets introduced in a namespace, rather than needing to get denied by any of these other rules, it could just get dropped because it hasn't matched those label contexts. So yeah, if you're not using Calico Cloud or you're just using open source, the policy rules still work the same. So if anyone's wondering, oh, this is an enterprise functionality, it's the same. The only thing you're missing out is there's no concept of tiering in open source Calico. So I scratched out the fields for tier in your specification, and also in the policy name itself, we have a kind of a syntax of tier.policy name. So if you just remove the tier, then the rules work exactly the same. So with that, I'm just going to put in the closing notes. I hope this session was useful. I've put a totally separate session on using, actually conducting a lot of this security best practice in Rancher Desktop. So Rancher Desktop's fun. You can run this utility on your Mac machine like I did, or on a Windows PC, or it can run on a Linux system. It really doesn't matter, but you can run it on your local machine. That's the beauty of it. Once you have it installed, I put a GitHub repo to, installing Calico on it, because the process is just a little bit different. I used Kind. And with that, if you're not using, like Rancher Desktop is a great way to get to learn Calico if you're new to it and following those best practices. But if you're already, familiar with Calico and Kubernetes, and maybe you're already using it and you just would like to learn more, we have an Academy link there. So academy.tigero.io. It's a free course. You can sign up. You can learn more about Calico. It's an operator course. So, it's better if you, maybe you're a DevOps admin, or maybe you're in SecOps. So, either way, you'll learn a lot about how to use Calico for security, but generally for networking as well. And I linked also the PCI white paper for today's session. So I hope you found it interesting, and I hope you're having a great day as well. Bye for now.